Hi and welcome back. Okay, so the diode matrix that I built, it's kind of working, but I think it would be a lot better to do that on a custom PCB. So I'm going to have a crack at designing up the schematic and getting PCBs made. Now the biggest problem making that was soldering up the interconnections on the 1x16 headers. And on a custom PCB that should be absolutely trivial. You need 16 of these. Now what I'd like to do for this one is include the driver circuitry on the PCB, because then that's going to be a little bit more useful. And I'm also going to put a line driver in so we don't have any concerns about the low level of current we can draw. Now the 540 is an inverting version of the one I've been using most of the way through the processor build. And with it being an inverting version, it's not only slightly quicker, but it will also mean that we will just be a little bit more clearer about the diodes we're putting in, as we'll be placing one diode for each set bit we want in our memory array. Since we got enable inputs on this line driver, I think it would be a good thing to expose a select line just in case I ever want to use this in a bigger system. That would make it quite easy to have like more than one of these with higher order address bits selecting between them. I'll obviously be interweaving these in the actual matrix when I design the PCB, but separating out the row and column aligned ones like this makes life an awful lot easier. Okay, I think that's the main circuit complete. It'd be nice to get some LEDs in there. Oh, I think that's done. Just realised I've missed the pull-up lines on the internal data. I also missed a header for the data out. So this is the original kind of breadboard thing I made for the diode matrix, and the idea was I would use these pin headers as kind of breadboard holes to poke the diodes in. But this did suffer from a problem that they're not really designed to be used like this, and the legs on these pins are a lot smaller than the pins normally go in here, and so they're a little bit loose. So while I got it working, if I nudged it or just left it for a little while, I'd come back and suddenly I'd need to find the ones that needed to be waggled around a bit. So I want to do something different this time. I think this will solve the problem. So what I've done here is used a female DuPont connector, and I've wired the diodes into that, and then I'll use male pins instead of the female header here, and I can poke these in, and I should be able to get a really good, secure, robust connection, because that's what they're designed for. Now in theory I need up to 128 of these, but obviously it would be a pretty boring diode matrix if I just filled in every gap. So probably about half that, 64-ish, is the most I'll need. Now I 3D printed this little widget to help me with constructing these. It's just got a shaped recess that can take a diode. And I made the width here from each of the sides of the diode the right length. So if I cut it like that, I get the legs of the correct size. Now I need to attach the pins themselves. And that's where the second end comes in. I shaped it just so that if I just hold it up tight against the side of the crimping tool, it will crimp it exactly how I want. One flaw of the process is I can't get this in the other way around because of the fatter end, so I have to hold the crimping tool upside down to do the other side. Wasn't a big enough flaw to remake the tool for though. Then for each pin I just need to bend the top over and wedge them into the shells. Preferably not like that. Okay, so they look reasonably neat. They're not perfect because some parts of it are still very manual, but without this they'd be a lot less even. Don't worry, I'm not going to make you watch me make 64 of them. Let's move on to the next step. I was very pleased to receive this. This came via one of the couriers I won't mention by name, but they're not regarded as very good, so I kind of had a scheduled package delivery text message on kind of 3 sequential days, followed by the we couldn't access the location responses, when I know that wasn't the case. I know other people have these issues as well, but I finally got them and now I know what the delivery was. So I got 10 of these boards. I doubt I'll ever fill in all of them, but yeah, that's pretty nice. So it's actually not far off the size of the original, but instead of all this wasted space, I've got the driver circuitry. Let's have a crack at soldering that up. I meant to order some 10Ks for the pull-ups here, but I neglected to do so. I do have some 5Ks though, which should get us working. Don't know why that wasn't working initially. I think these are the best test probes. Okay, I'm going to solder on the pin headers next because that gives me a way to grip it. Okay, so this board is designed to sit on the edge of a breadboard like this, which gives me easy access to the input and output pins, and it picks up the power and ground itself. Okay, I've just realised I've put the address lines in here left to right rather than right to left, because that matches the way they start off on the chip over here. So that would be why I did that. Right, so that's 0, 1, that'd be 3, that'd be 2. That's a shame, that feels like a bit of imperfection on the circuit, but there might be a version 2 one day. It's all working beautifully though. If I update this circuit, I'll also wire the select line into the two 138 chips, just so this LED goes out when it's deselected. I know I wired it into the output enable up here. Okay, need some headers in there. I believe we've got a working diode matrix. Right, I'm going to put all my soldering stuff away and then we can look at giving this a proper test. Okay, so I built the same test circuit as we were using before. So basically our circuit should be pretty much exactly as what we had with the temporary board, but the 193 counter chip that I'm using to test cycle the inputs is off on the breadboard here, and on the board we've got an inverter here, so we have to flip our outputs. But it just makes more logical sense that we're putting a diode in everywhere we want a 1. So I did have a play on this while the phone was recharging to shoot this bit of video, and you can see that everything is a lot more stable here. That's really good. So what else can we do with the diode matrix? We talked about a few things last time, but we've got a stable one now. So there's a little 7-segment display. Might be quite interesting to play with that. I think the common pin for the right hand digit is there. I believe the standard numbering for a 7-segment display is like this. So I'll put A to G in bits 0 to 6 if I can. Right, that's A. That's B. That's F. Don't really want the full stop. It's G. C. D. And E. Zero, everything but G lit up. Okay, I'm mentally projecting myself forward to the job that I actually want to use this for. Okay, so 1 is going to be like so. Starting to suspect this one would have been easier with the inverted lines. Okay, I've done numbers 0 to 9, so that shows one way we can use a diode matrix to do some interesting decoding. I don't think I've quite cut enough diodes to do 0 to F for the first digit of hexadecimal. It would be interesting at some point to then add the multiplexer circuitry to drive 2 digits, but right now I'm just trying to play with it, test it, and get confidence that if I build this into a more important section of my CPU, I'm not going to run into any problems. I think it would be interesting to try interfacing this to an external circuit that's not kind of my ultra basic stuff. Okay, so in the last video we attempted to write out the words diode matrix test in ASCII. So I'm going to try and do that one again, only we're not having to invert the logic we're putting in here anymore. In hindsight, I would have done a test phrase with more than one space in it, because they're really simple. I've got a couple in the wrong way around, and they interfere with everything. Maybe it was just the one. Okay, right, circuit to plug it into. How about the EEPROM programmer? So we've had a look at the pinout before for the AT28C16, and so I've made a little quick hack Vero board project which I think gives us easy access to the pins we want. Lower 4 bits of address put in here, and the data, if you remember, we got 5 pins on one side and 3 pins on the other, but I just kind of brought them across with short jumpers, and I can have an 8-way DuPont cable connecting that up. I believe we're recommended to tie the power and ground lines over as well. Okay, now let's see if we can read that. Okay. All right, firstly, that's absolutely awesome. We appear to have one character wrong. That should be D-I-O-D-E. So 7 should be an O. Back to my little reference. So that's 4, a space, and 2 ones. Hang on, so the O is 6F and we're getting 2F. So we're missing 4, which is the 3rd bit from the top. Oh, hang on. No. I just wasn't looking at the right row. Okay, this is not easy when they're already packed in tight. Okay, when you get a big solid row of these connectors like this, they do start to get a bit of a squeeze. Let's try reading that. Power it back on and try reading that. Yes. Okay, that is absolutely awesome. So we've got a diode ROM here operating as an actual ROM and fulfilling the kind of specifications for levels and all of that stuff sufficiently well to be recognised by the EEPROM programmer. That's awesome. Is there anything else I can do quickly? Could use an extra address bit. Put that into the enable line and read that. There you go. That's kind of nicer. Okay, I am really chuffed with this. I had big plans for the diode matrix, and then when I realised the one I built before was a little bit on the ropey side with the poking the diodes into these holes, I was wondering if I'd have to rethink my plans for what I'm going to do with this. It's probably no big secret that I'm going to factor one of these into the the ALU on my processor build. I'm going to finish the bits I'm working on and then move on to that next, I think. But this should be really good because we've got 8 control lines in the ALU, so we've got 8 outputs here, and I'll be able to just plug in these little jumpers wherever I want a line to come high. So we should be able to kind of reconfigure it around and make the ALU do what we want for up to 15 different operations, assuming we're going to keep one as a kind of a neutral, undefined. But anyway, this is good. I'm feeling very good about this. Thanks for watching. Goodbye.